Hey everyone, this is Joe, and this is my presentation on emerging technologies. I'm going to cover four emerging technologies today. The first one being what if hypothetical implementations in Minecraft, or WHIMC. Second, we're going to cover augmented reality, more commonly known as AR. Third, we'll cover 3D printing. And finally, we're going to cover blockchain. So what if hypothetical implementations in Minecraft, WHIMC? The project was funded by National Science Foundation and headed up by Chad Lane, an associate professor of educational psychology at the University of Illinois. And the goal was to encourage kids in STEM, or science, technology, engineering, and math, through the use of WHIMC, while using a familiar format as a context for generating interest. Lane wanted to get children asking the questions, what if? What if our world had no moon? What if we had two moons? Could we even survive without the moon? What if the world were twice its size? What if the world was tilted ever so differently? What if the sun was cooler? The platform by which he chose to do his research was through Minecraft. Minecraft being the second most popular in the history of video games, with 100 million players worldwide, is essentially a virtual sandbox world where players can explore, interact, and create just about anything they want. They get to use a variety of resources and materials, have a near indefinite digital landscapes and dozens of unique ecologies and environments. The team was seeking to develop and advance new approaches to science, technology, engineering, and math through learning in more informal environments like museums or maybe after-school programs and summer camps. As an example, at these summer camps, kids would utilize these what-if worlds and or create their own what-if world. And by doing this, they were able to interactively observe the scientific consequences of astronomical changes to the environment. So what would the impact of having two moons have on our environment? What would that do to our plant life? What would that do to our oceans and tides? It was a great example of getting kids involved with learning within a format that they can relate to and are already familiar with. Next, we're going to cover augmented reality, or AR. Augmented reality, defined by realitystechnologies.com, is an enhanced version of reality where live, direct, or indirect views of physical, real-world environments are augmented with a superimposed, generated image over a user's view of the real world, thus enhancing one's current perception of reality. Or essentially, in layman's terms, placing a digital overlay over our real world that we can then interact with. Four of the main methods of superimposing digital images over our real world are: the first being marker-based AR, or also called image recognition. And this uses a camera or some type of visual marker, such as a QR code, to produce a result only when the marker is sensed by the reader. Next is markerless AR. In that, markerless AR overlays relevant digital information onto our real world based on location. And it does this by using GPS or a digital compass or velocity meter or accelerometer that's embedded into a device. This is great, as we can see in this picture. It's a great example of walking down the street and there's restaurants in front of us, and being able to see as we walk down the street, in this example, the name of the restaurant and any ratings that it may have received, as well as maybe contact information such as a phone number. Next, we have projection AR. And that works essentially by projecting artificial light onto real-world surfaces, which we can then interact with. Superimposition AR. That either partially or fully replaces the original view of an object with a newly augmented view of that same object. And a great example we see here in this picture is IKEA app. The IKEA app essentially, you use your device and within your room you can kind of try it before you buy it. You can place a piece of furniture in the corner of your room and you can see what it would look like in your room prior to you even buying it. Another great example is the Lowe's app. The Lowe's app, you could hold up and place a lighting fixture in your room prior to buying it. And you can see what it looks like. Next, we're going to cover three-dimensional printing. Printers can be divided into two basic groups. The first being additive, where a machine deposits layer upon layer of material, progressively building on the model. And that's the most popular. Reductive is a little less popular, and that's kind of the reverse of additive, where it begins with a block of material, which it then progressively cuts away little by little. The two most common additive types of 3D printers are fused deposition modeling, or FDM. And the FDM printer feeds a spooled filament into a hot nozzle which melts and extrudes the material in an XY plane, producing a layer of printed material before the nozzle raises or the print bed lowers and a new layer is deposited. This just happens over and over and over again, creating a highly intricate and detailed object. Next, we have stereolithography, or DLP. DLP is quite a bit different in that it uses an ultraviolet laser to draw layers into a photopolymer resin bath. As each layer is hardened, the printer bed descends and a subsequent layer is built. So what about some usage cases in 3D printing? Medical is a great one. What if you could 3D print a anatomical structure or a bone to be able to then present to a patient so they could help them understand what's going on or what the doctor's actually talking about. And then there's manufacturing, prototyping specifically. Instead of spending a bunch of money and milling out actual components at a higher cost, 3D print them. The cost is much more effective, and if edits need to be made to the component, it's much easier to print them than to mill out a whole new component. And then there's the fun part of it, of 3D printing. You can create models, you can do art. What about a very intricate model of a building? There's so much you can do with 3D printing. Finally, we're going to cover blockchain. So here's some quick facts. As of April 2018, 16.7 million people in the US were victims of identity theft. That's an increase of 1.3 million people since 2016. Now, blockchain can be a complicated process, but essentially it starts out with a buyer and a seller, or person A and person B, and they're going to have some sort of transaction. That transaction itself is called the block. That block is then given a digital fingerprint, and that's called crypto hashing. Crypto hashing is a fixed sized alphanumeric string, and that's essentially encrypts the block so then it can be then distributed into the database. And the database is a peer-to-peer network. It's not one single database that stores all the information. The peer-to-peer network has a bunch of different computers in it that are involved in it, and those computers are called nodes. One of the great things about blockchain is that there's a check and balance process in these nodes. So if one of the nodes is corrupted or somebody goes in and tries to steal information, that node will then, the check and balance will highlight it as an issue and will prevent the transaction from moving any further. Also, these nodes in this peer-to-peer network are a decentralized network. So as I mentioned, there's no intermediary in the middle. There's no database that stores all of our information that could then be hacked and millions of people are exposed. And as I mentioned, there's no intermediaries. There's nobody in the middle. The transaction comes from point A to point B or from person A to person B. There's no middle company having a financial gain on us. Some good examples of intermediaries are your eBay, your Amazons, your PayPal. They all act as a transactional correspondent from buyer to seller or seller to buyer. So wrapping up, the four emerging technologies that I covered today are what if hypothetical implementations in Minecraft. And this is great. It gets kids involved in science, technology, engineering, and math in a format that they are familiar with or that they're excited to use. Second, we covered augmented reality, which bringing interactions to our current reality, overlaying information into our real world. 3D printing, creating a new product in real form. This is great for reducing costs in manufacturing or improving education and communication to patients within the medical field. And blockchain, creating a safer digital world by having checks and balances in place and eliminating the intermediaries between person to person. And these are all great technologies that are either in play or getting better and better over time. But as our world grows and our technology become more advanced, we'll continue to push the boundaries in teaching our youth or teaching in the medical field or creating new technology to print new items or creating a much more safer digital world through security. It'll be exciting to see in a couple years of what our technology looks like. It's growing so fast. Well, thank you for listening to my presentation. Hopefully you've learned a few new things. Thank you.